Okay, my name is Tatsuru Shirafuji from Osaka Metropolitan University, and my presentation title is Surface Launched Plasma Bullets. Here is the acknowledgement for the grant. Okay, so now I'd like to start my presentation. The conventional plasma bullets, maybe you know very well, and this is APPJ, and if we observe this phenomena by ICT camera, so you can see propagation of plasma bullet like this. And the conventional plasma bullet is launched from this kind of glass tube. And what we talk about today is surface launched plasma bullet. This is what it looks like. So here is a glass plate here, and here's a metal plate. And if we apply high voltage, before that we must feed helium gas in front of the glass plate, and then on the back side we put a glass metal plate and apply high voltage pulse. So by applying high voltage pulse, so we can observe this kind of launching of plasma bullets and propagation. So because of propagation of the plasma bullet, so this lesion can propagate very long distance like this. So this is what we observed today in our research. And what can we use this surface launched plasma bullet for? So we suppose, so we can use this inner surface treatment of narrow channels. So for example, hydrophilic treatment of inner surfaces of the bone regeneration scaffold, something like this. So this is used for bone regeneration like this, but this is made of polylactic acid, so this is hydrophobic, so hydrophilic treatment is required. And if we can realize something like this, so we can treat entire inner surface of the scaffold like this. So here is what we did. So this is the reactor for the treatment of the scaffold, and this is schematic diagram, and this is just a simple dielectric box, and on the bottom plate we have electrode and apply high voltage. Before that, we must fill the box with high purity helium gas. And if we put the scaffold like this, so we can expect the hydrophilic treatment of the scaffold. So this is what we get. So you can see very nice plasma inside the glass plate. So what's the difference between conventional direct barrier discharge from and this new surface launched plasma bullets? So important feature is the propagation of sheet-like plasma bullet. So this looks like something like, but sheet-like plasma bullet is propagating. And another feature, important feature, is this is relatively big. So in conventional direct barrier discharge, so DVD is available only in a narrow channel, narrow gap. So in comparison to the conventional DVD, this is very, very large. So, okay, and this is what we got. So we put the water droplet on the scaffold treated by a surface launched plasma bullet. So by changing thickness, so even if we had put a very large scaffold like this, so the scaffold becomes hydrophilic, and the water permeability is very, very excellent. So even in very short time, 3 minutes treatment, so we can get very nice results like this. Okay, so detail will be presented in a poster session, including numerical simulation of the propagation of the surface launched plasma bullet like this. So please come to my poster. Thank you very much.